Welcome back. So today we're going to be talking about law of sines and cosines. So you should have these two foldables in your notebook, page 306. And so we're going to be going through those. So the nice part about our law of sines and cosines is this is kind of the ending to our trig unit. So we've been talking about all these right triangles. Now we're going to talk about any triangle that's not a right triangle and how do we use trig to help us solve for missing pieces on those. So if you notice here at the front of the foldable for law of sines, we typically use this when we're working on angle side angle or angle angle side. Okay, and then for our law of cosines, we typically use this one if we're working on side 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 or side angle side. All right, so we're going to do some examples here. So we're going to start with our law of sines. So we'll come up here to the top one, and I'll actually zoom in just a little bit here. So it makes it a little bit easier to read that one. So for our law of sines, apologize there, that's really blurry. Let's fix that. There, that's a little bit better. So for our law of sines, we're going to be setting up some proportions. So law of sines, we're going to take sine of capital A over lowercase a equals sine of capital B over lowercase b equals sine of capital C over lowercase c. Now some things to remember. Capital letters. So we have this one, and this one. Our capital letters, these are angles. And our lowercase letters, these are sides. Okay, so anytime we use capital letters, those represent vertices or angles, and then the lowercase letters, those are sides. Okay? All right, so let's look at an example so we can see how we would actually use this. So I'm going to move up here to this top piece. So we're going to go ahead and label our vertices. So typically those are given to you. So then if I know that this is angle A, then the side opposite of angle A is side A. The side opposite of angle B is side B, and the side opposite of angle C is side C. So that's step one. We're going to start by labeling our triangle. Step two is we're going to pick the correct formula. So we have angle side angle. So if you remember from here, angle side angle, we're using law of sines. So we're using law of sines to figure this one out. So we have sine of A over A, sine of B over B, and sine of C over C. Okay, we're going to find our missing pieces here. So the first thing that I'm actually going to do is I need one of these ratios to be complete, no missing pieces. Well, if I look at the first one, A is 74, little a, I don't know. Sine of capital B is 51, little b, I don't know. I don't know angle C, and I know side C is 10. Okay, so which one of those missing pieces can I figure out? Well, I can figure out angle C because I know if I add up all three angles, I get 180. So I'm going to take 180 minus my 74, if I can write today, 74 plus 51. So that's going to end up being 180 minus, if we add those together, we're going to get 125. So 55 is our missing angle. Okay, so now I have sine of 55 over 10. I have a complete ratio here. Okay, so we're going to be substituting in what we know, and then we're going to solve. So I'm actually going to do two proportions here. The first one, I'm going to do sine of A. I don't know the little a, so we're going to have to find that one. And then I'm going to use sine of C over C because I know both the top and bottom there. So sine of C over C. The second one that I'm going to do is sine of capital B over B. And then I'm still going to use my sine of C over C because that's the only one that I know both top and bottom. So plugging in what we know angle A is 74. So sine of 74 over A equals sine of capital C is 55, lowercase c is 10. For the other side, sine of capital B, I know capital B is 51, and then lowercase b, I don't know that one, so I'm going to leave little b there. Sine of capital C is 55, and then little c is 10. So I'm going to be solving these two different proportions. Okay, so I'm just going to go ahead and divide that in half there. So let's start here with A. To solve a proportion, we're doing our cross multiplying or cross products. So I'm going to have 10 times sine of 74 equals A times sine of 55. I need to get A by itself, so I'm going to divide by sine of 55 on both sides. So now I have 10 sine of 74 divided by sine of 55 equals A. So then we're going to punch that into our calculator. So this one's a little different calculator than I use sometimes, but this is similar to one that several of you have. So we'll just use this one for our example today. So we are going to be taking, I write parentheses, 10 sine 74, and then I close my parentheses, divided by sine of 55. The reason why I put the extra parentheses is because I want this whole piece on the top. I don't just want sine of 74 over sine of 55 and then take that times 10. I want the whole thing on the top. We're going to hit equals. Oh, we have a mode set incorrectly. I didn't check my mode first. So we're going to check the mode. Give me 1 second. I apologize for that. That's not my normal calculator, so I have to adjust the settings on that. So we'll just go back to this one that I'm usually using. So we're going to take parentheses again, 10 sine of 74 divided by sine of 55, and then we get 11.73 something, so approximately 11.7. So 11.7 here. Okay, we're going to be doing the same thing over here for B. So cross multiplying first. So we have 10 sine of 51 equals B sine of 55. So now to get B by itself, we have to divide by sine of 55 on both sides. So on our calculator again, we'll go on this side. So we're going to be typing in 10 sine of 51, close in my parentheses, divided by sine of 55, and then we hit enter. So we get B is approximately 9.5. Okay, now we're going to look back up here to the beginning. These were in inches, so we're going to put our label of inches. Okay. All right, great job with that one. So let's move on to cosine. Sometimes we don't have enough information to be able to use law of sines, so then that's where law of cosine comes into play. So we're going to come down here to our law of cosines. So for law of cosines, again, I'm going to go ahead and label my vertices here for us right quick. So we've got A is here to the right, then B, and then C. Okay, and then we'll come down here and fill in our law of cosine. So there's actually 3 equations here. The first one is A squared equals B squared plus C squared minus 2BC cosine of angle A. The second one is if we're finding side B, so B squared equals A squared plus C squared minus 2AC cosine of angle B. The third one is if we're trying to find side C, so C squared equals A squared plus B squared minus 2ab cosine of c. So these really just depend on what side you're trying to find or what angle you're trying to find. Okay, we're going to start out by trying to find a side. So we're going to be looking for either A, B, or C when we come up here. So looking at the top at our triangle, we know the angles. So now we need to label the sides. So we have side A, side B, side C. The next is we're picking the correct formula. So if you remember when we look over here, we have, for this one, we have our side angle side, which is this piece. So we're going to be using our law of cosines. Okay, we are trying to find side A. So we're going to use this top formula because that one's the one that's solved for A. So A squared equals B squared plus C squared minus 2BC cosine of angle A. Now if you look here, there is a pattern. Whatever side is over here is the same angle that we're using. And then these two sides are the same two that you see here. Okay, so our next step, we're going to substitute in what we know. We don't know little a, so we're going to leave that. Equals little b is 9, so 9 squared. Little c is 15, so 15 squared. Minus 2, b is 9, c is 15. Cosine angle A is 30. So we plugged in all the different things that we know to write our equation. Okay, so then from here we're going to simplify. So the first thing I'm going to simplify is my 9 squared plus my 15 squared. The next thing I'm going to simplify is this 2 times 9 times 15. Okay, so on our calculator I'm going to take 9 squared plus 15 squared, and we get 306. So 306 minus, the next one is going to be 2 times 9 times 15, which is 270. So I'm going to put 270 cosine 30 equals my a squared. So then the next thing I'm going to do is I'm going to type in this whole right side because I have everything there that I need to solve. So 306 minus 270 cosine of 30 equals, and we get 72.17, and it goes on and on. So we're going to round that to 72.2. So a squared is approximately 72.2. And that's the reason why I didn't plug in this cosine of 30 here at the beginning, because I knew this was going to give me a decimal. So I just did this front piece, which is kind of like a coefficient to a variable. So I did this front piece, and then I left the cosine of 30 and could use that later. Okay, so now that we have this piece, I'm going to take the square root of that 72.2, and I get 8.497 and on. So we're going to round that to 8.5. So square root both sides, and we get A is approximately 8.5, and then my unit is centimeters. Okay. All right, so we're going to do one more example. I wanted to show you an example of when we have a side, side, side problem. Okay, so if you look on your practice problems, we have number 21. It's a side, side, side problem. So we're actually going to be working this still using our law of cosines because it is a side, side, side. So here I'm going to go ahead and first again label. So I have side A, side B, side C. And then I'm going to be using my law of cosines still. So I'm going to start with the first one just like we did before. So I'm going to use a squared equals b squared plus c squared minus 2bc cosine of angle A. The next step, I'm plugging in what I know. I know A, so I have 25 squared equals b is 23, that's going to be squared, and c is 14, that's squared, minus 2, b is 23, c is 14, And then cosine angle A, we don't know. Okay, so just like I did last time, I'm going to simplify. So I'm going to simplify that first piece there with my two sides added. I'm actually even going to simplify that exponent. And I'm going to simplify this piece in front of my cosine again. Okay, so using our calculator, 25 squared, 625. I'm going to take 23 squared plus my 14 squared, and I get 725. And then I'm going to take 2 times 23 times 14, and I get 644. And then that's cosine of A. Okay, so now from here, the next thing I'm going to be doing is I'm going to move this 725. Okay, because remember the 644, that's part of cosine A. That's all multiplied together. So I'm going to move this 725. That's like a constant. So I'm going to subtract 725 from both sides. So then I'm left with a negative 100 equals, I have negative 644 cosine of A. All right, so now I have all these things are multiplied, so I'm going to divide by that negative 644. Okay, I'm not going to do anything with this piece yet. You can simplify the negatives if you want to. A negative over a negative would give you a positive, but other than that, I'm not going to do anything. So I'm just going to say 100 over 644 equals cosine of A. Now, if you remember, we had something similar to this in the last section with our inverse functions when we were trying to find an angle. So we're going to divide by cosine or multiply by cosine to the negative 1. Remember, those were the same thing. So I'm going to multiply by cosine to the negative 1. So now I'm going to type in second cosine, so I get to the negative 1. And then in my parentheses, I'm going to put 100 divided by 644 and then hit enter. And I get 81.06699 whatever. Now it says on here we're going to round to the nearest tenth. So I'm going to round that to 81.1. So I know A is approximately 81.1 degrees. That is degrees. Okay, so that's solving for an angle. Now from here, I would go back to my law of sines to be able to solve for my second angle, and then I can use my third angle theorem to find the third angle. Okay, that is all that I have for you today. Have a great day. I'll see you in class.